Now in question 1 we're asked to draw some three-dimensional structures of PCl3F2. So the central atom in this obviously is going to be P, and it's going to have 5 different atoms bonded to it. And we're told that there are 3 different isomers, or that there are different isomers for this, and there happen to be 3. And when we consider this, obviously the chlorines and the fluorines may not be bonded in the same places. So for instance, if we make P our central atom and we put the F's at the poles, for instance, and that means we're going to have chlorines around the equator, and struggling to do that three-dimensionally, so chlorine, chlorine, chlorine. That's one possibility. Okay, and then we could have, for instance, one of the chlorines at the poles here, and a fluorine still at the pole down here, and fluorine over here, and then once again we could have chlorines out here. And just move that around a bit so we can get that in. And for this one we could have chlorines at both poles, and that means around the equator we're going to have one fluorine, another fluorine, and a chlorine. Okay, now you can mess around with drawing to see if you can get anything different, but you'll probably find that those are the ones. Now we're being asked to consider the bond angle. Now that's the angle through that, the FPF bond, and that's 180 degrees, which seems fairly logical. And then we've got the one here between FPF, and that's between the equator and the poles, and that's 90 degrees. And then we've got one FPF around the equator, and that's 120 degrees. So those are all the different bond angles with those different structures.